Good morning everyone. I am Mrs. Rikta Datta, PGT Chemistry from Kendriya Vidayalaya Army area, Pune. Today I am going to teach you the organic chemistry, and children, you should know that organic chemistry carries 19 marks. In the syllabus itself it's written that how the 19 marks are distributed. Among the 19 marks, the nomenclature part alone carries 2 marks. In that 2 marks, you get 1 mark, the structure is given, you have to give the IUPAC nomenclature, and another 1 mark is for where the name is given, and for that you have to draw the structure. So let me just complete all the IUPAC nomenclature, all the organic compounds, all the functional groups, that first. The first one I start with, the halogens. It is written, in general I am giving you the name first, it is written either haloalkanes when the aliphatic part is given, and when the aromatic part is given it is written as haloarene. Example, chlorobutane, 1 chlorobutane, 2 chlorobutane, that way. Similarly, when the halogen group is attached to the ring, it is called as chlorobenzene. I am coming to the next one. Alcohols. I am starting with the halogens. Halogens is represented by X. X can be fluorine, chlorine, bromine and iodine. If a halogen group is attached to an aliphatic part, it is given the name as haloalkane, and if the halogen is attached to the ring, then it is called as haloarene. For example, if I take this compound, then the name is given as 2-bromopropane. Bromopropane, the position of the bromine, so second position, so 2-bromopropane. And if a halogen group is attached to a ring, then this is called as bromobenzene. I hope it is clear. I am going to the second one, alcohols. Alcohols, it is the hydroxyl group, so I am putting dash OH. When I say dash, the dash part is attached to a carbon atom, alcohols. Alcohols, the name is given in the, it is given as alkanols. Like the name goes as methanol, ethanol, butanol, octanol. And if an OH group is attached to the ring, the name as such is given as phenols, the phenolic compound. I will just give an example of an alcohol. If I take this compound, just like this, here I am replacing the Br part with an OH, then I give the name this part as propan 2-ol. I can also write down the name as prop 2-ol. I have removed the E part here. I will also quote an example where I am going to retain E. If I take an example like this, where I have got 2 hydroxyl group, in that case, how do I give the naming? Now, I cannot give the naming as butanol because there are 2 hydroxyl group. So, what I do is I combine this ol part. There are 2 ol part, so I give the name as di, diol. Now, since the word di is there should be 2 numbers. So, first, second, third, fourth. So, I am giving the name as 2, 3 hyphen. In front of that, alkane, the 4 number it is, and the name goes as butane. I want everyone to make it clear, here I have kept E, the E is retained here, here E has been removed, because there is only 1 OH group and there are more than 2, 3, then I am going to retain the E part. I am coming to this topic, phenol. If I draw the ring here, to that if I attach an OH group, then the word goes as phenol. To phenol, suppose I am attaching something here, then I say this one as with respect to OH group, this is second position. Then the name goes as 2-chlorophenol. In the 11th standard, you have already studied the position. You may also come across some places the name goes as ortho, meta as well as para with respect to a group attached. Now, here I can also give the name here as orthochlorophenol. When the Cl group is here, then this one is meta. When the Cl is present here, then it is para. It is not necessary if I draw a ring. These are always ortho. This is not at all correct. Ortho and the meta as well as the para are decided by the group already attached. This part you should be very, very clear. Suppose I am putting OH here. I am telling this is also phenol. Even this part also was phenol if I remove the Cl part. Now, in this case, the ortho position goes at these 2 points, and thus with respect to a group which is already attached to the ring, I will be able to decide where is ortho, what is meta, and what is para positions. I am going to the next one, the third functional group. I hope the halogen and the alcohol is clear to everyone. I am coming to the third functional group, that is the carbonyl group. The carbonyl group, it is written this way. In the carbonyl group, this C is called as the carbonyl carbon. Now, the carbonyl group I can divide into 2 parts, one as aldehyde group, the aldehyde group, another one as the ketonic group. In the aldehyde group, I am just going to put an H here like this. When I put a dash like this, there is a carbon chain attached, and when I go for ketonic group, nothing here also carbon, here also carbon. In the aldehyde group, I have got a CHO, and in case of ketonic group, I have got dash dash CO. Like how I have told you for halogen, I have made a term called as haloalkane, haloarene. For alcohols, I have made a term called as alkanol. Like that, what term should I go for aldehydes? In general, the word. I will just tell you the example first, and then you people should be able to predict. I am giving the example, butanal, ethanal, methanal. In that case, what should be the term? The term goes here as alkanal. The term goes here as alkanal, this al part. Similarly, in this case, ketonic also, you should be able to think what will be the name. Always you see that the name is somewhere coming from the function, this word itself. So, here the word is ketone. From ketone, I am writing the word here as ketonic group. I will give you the example, propanone, butanone, pentanone, and thus I can use the term here as alkanone. Now, in case of alkanal, the simplest aldehyde, here if I just put an H, this becomes the simplest aldehyde. The simplest aldehyde, and now how do I give a name for the simplest aldehyde? This one I can write here as either HCHO, or this can be even clubbed as CH2O. One of the example I have quoted here, the simplest aldehyde. What name can we give to this? Alkanal. Just count here how many carbon atoms. There is only one carbon atom. One carbon atom, alkane is methane. So, its corresponding alkanal goes as methanal. Thus, I am writing the word here as methanal. If methanal goes as the simplest aldehyde, we expect for the ketonic group alkanone, the word should be methanone. Let us say whether methanone exists or not. If I imagine this part with the ketone part, I am just writing here an H and H. This part do not become as ketonic part because this one turns out to be an aldehyde. Even this part turns out to be an aldehyde, and thus methanone do not exist. Let us go to the next in the homologous series. Let us suppose if I take one side as the carbon atom, in that case let us complete the structure. I am just putting this part as CH3. I am just putting this part as CH3. So, in this case if I feel this is looking like a ketone, but here also you see the CHO goes as to be an aldehyde. Aldehyde is coming under this category, and thus ethanone also do not exist. Let us go to the next in the homologous series. Let us start with the 3 carbon atom. So, here if I place a carbon and then you satisfy the valency, and thus you see that this is a ketone, and hence this part you should be very, very careful. Whenever you see any organic compound just with the C double bond O, you should not think that this is a ketone. This part is a ketone provided this carbonyl carbon is attached on both the side with carbon atom, then only it is a ketone. This is a probable mistake where every time the student do any aldehyde, anything, they are always thinking that to be a ketone. And thus if someone is asking you which is the simplest ketone, the simplest ketone goes as to be propanol. Whereas the simplest aldehyde goes out to be as the methanal. So, a simplest ketone, I can write down this part like this. So, propanone, butanone, pentanone. Now, in case I write here, I am just writing here an example of a ketone. I am writing here something like this. I am just writing the carbon skeleton part. I did not put the hydrogen here. This is a ketonic group, this is a ketonic group. Why it is a ketonic group? Because this carbonyl carbon is attached on both the sides with the carbon atom, and hence it is a ketonic. Suppose if I just remove this carbon atom, put an H, then this is not a ketone, this turns out to be an aldehyde. Now in this case, can I give the name this part? There are 5 carbon atom, alkanone, so the word goes as pentanone. 5 carbon atom, it is a ketone, the word goes as pentanone. How do I distinguish this pentanone with the upper part pentanone? Can I just write down the word as pentanone here? Now here you see the position of the keto group. So this one is in the 3rd position, this one is the 2nd. So here I write down the word this part as 2, this one I can write down as 3. Or the latest one, whatever IPC nomenclature designed after 2004, the word goes here as pentan 3-one. And this one goes as pentan, you should be able to make out now, this one goes as pentan 2-one. Should I write here as propan 2-one? This is not necessary, because if you see from either side, this goes as propanone only, and thus 2 need not to be written here. Now in this case, one of the question asked in 2006, in the question paper, you hardly get the structure which is split up like this. This is how the question in the question paper, it was printed, and so you should be first able to make out how it is. So this is a ketonic group, this is a ketonic group. Try to split it up first. So this goes here as double bond O, this part goes here as double bond O. Now how do you give the name for this compound? As I told in case of alcohols, diol I made it, because there were 2 OH groups. Here there are 2 ketonic groups, so this is one part, there are 2 one parts, and hence I write at the end as dione. Since I use the word here as di, I should put 2 numbers there, and here the number goes as 2, 4 dash dash. There are 5 carbon atoms, and then now next you should be able to make out, should I go for the word pentan or should I go for the word pentane? Now since the word here di it is, and hence the word goes this part as pentane. A very important question, this has been already asked in the CBSE examination. I hope it is clear what is an aldehyde, what is a ketone, both of them are coming under carbonyl group. I will go to the next one, that the 4th one as the carboxylic group. Carboxylic group, a base part you have also studied in class 10th, where you have studied little bit about the methanoic acid and the ethanoic acid. I hope you people also remember what is the functional group for the carboxylic acid. A carboxylic acid also has got some part of like this. The 4th one I am coming to carboxylic acid, the structural formula COOH. If I split up this part, it goes as single bond C double bond O OH. Now when I see this structure, we always feel that there is a ketonic group, it cannot be a ketone because there is no carbon atom here. There is an OH group here, and this part a ketonic group, like this we feel it. Now how to give the name for this compound? Once again, like previous I have told you, alcohols, for alcohols the word goes as alkanol, and for aldehyde the word goes as alkanal, for ketone the word goes as alkanol. Now similarly for the carboxylic acid, the terms are like this. I am giving some of the examples. Ethanoic acid, butanoic acid, octanoic acid. In that case, the name goes here as alkanoic acid. This is alkanoic acid, and if the carboxylic group is attached to a ring, then the name goes here as benzoic acid. Benzoic acid. One of the example I am citing here is CH3COOH. This one, if I split it up, this goes as CH3C double bond O OH. And in case of benzoic acid, a ring, and then other carboxylic acid, benzoic acid. Now next I am going here next to ethers. Ethers you would not have studied in class 11th. Ethers I am telling you now as something a different functional group. Ethers I am writing it like this, single bond O single bond. Till now whatever functional group we have studied, I will just write it here. I am putting one as single bond dash, this is for the halogen, single bond OH, this is for the alcohols, single bond CHO, this is for the aldehydes, single bond CO, single bond, this is for the ketone, single bond COOH, this is for the carboxylic group. I am starting with the next one, this part as, these are the carbonyl groups, the next one as single bond O dash. Among all of them, till now we have studied only one of the functional group for which I am putting a single bond on either side. Similarly, I have got single bond for oxygen atom on either side. Now, whenever something is single bonded on either side, one can classify this into two parts. I am doing it for the ethers, and you should be able to do it for the ketones also. Like here, one of the example I am citing here as CH3OCH3. Here I am writing here as CH3OCH2CH3. Now, if you see this group, this is the functional group. On either side, I have got similar groups. Here, on either side, I have got different groups. When on either side of the functional group, I have got similar groups, I use the term called as simple. The functional group here is ether, so this one is simple ether. Simple ether can be also written as symmetrical ether. Like that. I did not touch for the ketone. I wanted you people to try out. Similarly, for ketone on either side, I will be having a simple ketone, and now for this one, like here, this one is simple ether. The other part, this is called as mixed ether. Mixed ether, or this one is unsymmetrical. This is not divided into two equal halves, and thus this one is unsymmetrical ether. I hope you will be able to try out for the ketones. I did not do it for the ketones. I want you people to try it out. You will be having similarly the simple ketones or symmetrical ketone, and similarly here you are going to have mixed ketones or unsymmetrical ketones. For ether, we give the name as, I am writing here the name as alkoxyalkene. Till now, I have been using the word alkane only once. Haloalkane, alkanol, alkanal, alkanone, alkanoic acid. In this case, 2 times. Alkoxyalkene. Which part is alkoxy? Which part is alkene? Now, when I am taking the example of mixed ether, this is the oxygen atom. You just see which side I have got more number.